Have you ever looked up at the night sky and wondered how all of this came to exist? Every star, every planet, every tiny speck of cosmic dust had a beginning. Even our very own sun and Earth were once just clouds of gas and dust drifting silently in the vast emptiness of space. Today, we're going on a journey back 4.6 billion years to witness the birth of our solar system. A story of chaos, collisions, and cosmic artistry. By the end, you'll never look at the night sky the same way again. Our story begins in a giant cloud of gas and dust called a molecular cloud, located in a quiet corner of the Milky Way. These clouds are massive, sometimes hundreds of times the mass of our sun, cold and dark. Gravity works quietly, causing tiny dense regions to collapse and pull in surrounding gas and dust. This collapse marks the first step in the birth of a star. One of these regions eventually formed a protostar, the early version of our sun. At the same time, the leftover gas and dust around it began to spin, forming a flat, glowing disk, the protoplanetary disk, the nursery for planets, moons, and asteroids. It's amazing to think that everything in our solar system, Earth, Mars, Jupiter, even the smallest asteroid originated from this spinning cosmic pancake. At the center of this disk, the protostar grew hotter and denser. Pressure and temperature climbed until nuclear fusion ignited. Hydrogen atoms fused to form helium, releasing enormous amounts of energy. This moment marked the birth of the sun as we know it, a blazing ball of light that would dominate the solar system for billions of years. But the sun wasn't alone in its creation. Its intense heat and solar wind began to shape the rest of the disk. Dust and gas far from the sun remained cold and sticky, while materials closer in were melted, vaporized, and reshaped. This difference would later define the types of planets. Rocky ones like Mercury, Venus, Earth, and Mars near the Sun, and gas giants like Jupiter and Saturn further out. The protoplanetary disk was alive with motion. Tiny dust grains collided and stuck together, forming pebbles, which then formed boulders, and finally planetesimals, the building blocks of planets. Imagine billions of these objects, crashing, merging, and sometimes shattering. Over millions of years, gravity helped the largest of these planetesimals dominate, pulling in smaller ones and clearing their orbits. These growing bodies became protoplanets. Closer to the sun, where it was hot, only rocky materials could survive, giving birth to the interterrestrial planets. Farther out, ices and gases could remain stable, allowing the outer gas giants to form massive atmospheres. Collisions were brutal. The Earth itself was shaped by a giant impact with a Mars-sized body called Theia, which created the Moon. Every scar and crater in our solar system tells a story of these violent beginnings. Farther from the sun, beyond the frost line, icy materials could accumulate rapidly. Jupiter, the largest planet, formed first, its enormous gravity shaping the rest of the solar system. Jupiter acted as a cosmic guardian, deflecting comets and asteroids that could have otherwise struck the inner planets. Saturn, Uranus, and Neptune followed, each carving its own orbit and atmosphere from the leftover gas. Interestingly, these giants weren't always in the positions we see today. Astronomers believe they migrated, shifting and reshaping the solar system in a process known as the Nice model, leading to the arrangement of planets we recognize now. Not everything formed into planets. Many planetesimals remained small, forming asteroids, comets, and dwarf planets. The asteroid belt between Mars and Jupiter is a leftover collection of rocky debris that never coalesced into a planet due to Jupiter's strong gravity. Beyond Neptune lies the Kuiper belt, a region full of icy bodies, including Pluto. Comets from here occasionally travel toward the inner solar system, reminding us of our connection to the distant reaches of our cosmic neighborhood. One of the most fascinating questions is how Earth got water. Many scientists believe water was delivered by icy planetesimals and comets crashing into the young Earth. Collisions not only provided water but also essential organic compounds, setting the stage for life to emerge. The early Earth was a harsh, molten world, bombarded constantly. Yet, in this chaos, conditions stabilized, oceans formed, and life eventually appeared. The very cradle of life owes its existence to the formation processes that began billions of years earlier. Around 4 billion years ago, the solar system experienced a period of intense collisions known as the Late Heavy Bombardment. Asteroids and comets rained down on the inner planets, reshaping surfaces and forming many of the craters we still see today on the Moon and Mercury. Some scientists believe this bombardment also delivered additional water and organic molecules to Earth, further preparing it for life. Over time, the chaos settled. The sun's strong radiation cleared out remaining gas and dust, leaving behind the structured solar system we see today. Planets found stable orbits, moons settled into paths around their planets, and small bodies either became asteroids, comets, or were ejected into deep space. Yet the solar system continues to evolve. Even now, asteroids and comets traverse space, and planets slowly shift over millions of years. The story that began 4.6 billion years ago is still ongoing. From a cloud of dust and gas to a magnificent planetary system, the birth of our solar system is a story of gravity, collisions, and cosmic timing. Every planet, moon, asteroid, and comet carries the story of this ancient origin. As we explore the solar system today, we are witnessing the legacy of processes that began billions of years ago. Next time you look at the sun or the moon, remember, they were once just pieces of a cosmic puzzle, slowly coming together in the vastness of space. The solar system is more than just planets and moons. It is a testament to the incredible forces of nature, the beauty of cosmic design, and the delicate balance that makes life on Earth possible. While we've traced its birth billions of years ago, our journey is far from over. Humanity is now beginning to explore, understand, and perhaps one day even extend the story of our solar system. From a cloud of dust to a vibrant, life-sustaining system, the story of our solar system reminds us that we are part of something unimaginably grand and ancient.